Hey there, Bendix here. Today's video's on starter motors, but specifically on this Bendix pinion gear on the shaft of it. We're going to go through a little bit of, I guess, sort of theory as such about how these gears work, with the aim to having that knowledge of how it works help you diagnose if you're having a problem with yours. So the symptoms you'll get when the Bendix gear is sort of failing is that it sort of spins up but it doesn't engage properly with the flywheel, or it engages with the flywheel sort of weakly and doesn't really turn the flywheel very much before it drops down. So there's sort of a bit of a continuum, a lot of shades of grey of what can go wrong with this, or what the symptoms are when it goes wrong. And they can sort of be a little bit confusing sometimes. It can kind of present as a bit of a weak starter motor, even though the motor itself's fine. If you're having trouble with the actual electric motor itself, I suggest you take a look at the either the installing a starter motor video, because that talks a bit about how the solenoid relay works, and also the how to repair a trim tilt motor, because that video essentially goes into fixing a problem with an electric motor, and that's pretty much identical whether it's a trim tilt motor or a starter motor. So take a look there. But if you're having trouble with this pinion Bendix gear engaging, then this is the video for you. This starter motor is from a Honda motor, but they're all pretty similar. Only real thing I noticed about this one is the relays mounted to the motor itself, which is not as common in outboards as it is in cars. So I've just got it hooked up to a jump starter here, and I'll just show you what happens when it spins up on the bench, and then we'll have a little talk about why it does what it does. So if I flick it on, what you notice is it spins up, the Bendix gear rises up, and then it starts to drop down again. So what I'll do is I'll just go grab a normal bolt and nut, and I'll explain why it does that. Now with this nut and bolt, if you imagine that the nut here is that Bendix gear that was spinning, the pinion gear spinning on the shaft, and that this bolt is the shaft of the starter motor. So what happens when it spins up, the starter motor starts up quite quickly. So as it spins, the starter motor sort of spins, and there's a bit of inertia in this nut. So if I turn these together, the nut doesn't rise up or down the shaft at all. But if there's a bit of inertia in this and I spin this shaft quickly enough, the shaft spins relative to the nut, and the nut would start to rise up it, because the threads are interacting with each other. And the exact same thing's happening with that starter motor. So the Bendix gear starts a bit down, the starter motor starts spinning, just a simple inertia in this holds it a bit still. But then what happens is, as it accelerates, the nut starts to turn. So this shaft might be doing, I don't know, arbitrarily 50 revolutions a minute, the nut's doing none. Then eventually the nut's doing 10 a minute, the shaft's still doing 50. And then eventually it gets to the point where the nut and the shaft are both doing 50 revolutions a minute, or whatever the figure is. I actually don't know what they spin up to. But as soon as they do spin at the same rate, the Bendix gear stops rising. Now, when it rises, it also rises up and hits against a collar. I'll show you that in a second. And that stops it as well. And as soon as it stops, it becomes essentially locked to the shaft, and then they'll turn at the exact same rate. But once they're turning at the same rate, it's locked in to the teeth of the flywheel. But then if the flywheel starts spinning, this is actually on a bit of a one-way gear. And that's when you've got a spring on the top that if they're spinning at the same rate, it actually lets it start to drop down again, because it is only geared to turn in one direction. A bit like a ratchet, I guess, on a spanner. But this is what makes this move up and down. The relative difference in the speed between what this gear is spinning and what the shaft's spinning. So as soon as they're spinning at different rates, it'll move up or down, to that matter, down the shaft. So that's the fundamental idea of what makes it rise up and down. Now, the reason we saw that rise up and then come back down again, not stay up, is that there's that inertial period where this is spinning faster. Then as soon as they're finally spinning at the same rate, the spring's able to overcome that and just slide it back down.
The spring can push it down more easily than you can push this because it's a much shallower thread. This has a very fine, steep, shallow thread actually, sorry, so it's a much steeper thread. And that steeper thread makes it much easier for that spring to push the gear back down the shaft. And at that point, they're both spinning at the same rate, so there's no reason for it to rise back up again. It'll just stay down the bottom until it stops, and then you start it again, and at that point, there's that inertia, and it takes a while for this gear to accelerate. So that's what makes it go up, spin up to speed, get to equal speed, and come back down.
So if I turn this shaft clockwise, or this gear clockwise, you'll see it rises up on the shaft of the starter motor the same way that nut moved along the bolt. This is because they're travelling at different speeds. Now, what happens here is actually this starter motor turns counterclockwise, but me turning this pinion gear clockwise is the equivalent of this shaft moving counterclockwise, or at least moving counterclockwise faster than the pinion gears moving counterclockwise. Now, once it hits the top, it gets to here, the two of them are actually locked at the same speed. It can't rise any further, so they're now spinning at the same speed, and it's engaged with a flywheel. But this pinion gear is actually on a one-way ratchet we're talking about, so I'll take it off in a second, we'll have a look. And then what this means is that when the motor starts and the flywheel speed on the actual engine exceeds the speed of this, it'll just move, it'll start to free spin, and that's when this spring gets strong enough to push it back down. So we'll take this off, and we do that by just pushing this collar down, and then there's a bit of a locking clip here around the top, so we're going to remove that clip, which lets us pull this collar off, so the spring off, and then the Bendix gear itself. To disassemble this, you just pull the collar down, and then you need to pull this clip off the top. That's a retaining clip that holds this collar on and stops everything sliding off. So here's a clip from another outboard, or another starter motor. Now, the best way to open these is to get some sort of pliers that can come in, and then they sort of separate the clip like that. If you don't have something like this that can come in, really it's a case of just using like a bit of a fine screwdriver, maybe even a pick like this, or some diagonal cutters, to see if you can get one edge of it off and then sort of work it around the same way you kind of work a belt onto a pulley, for example. So I'll get this off and then we'll start to disassemble it. Oh, before I do that, these aren't always that simple to push down. Sometimes they can get a bit stuck. So you can just find a right size socket and give it a tap down if it is caught up in here. Yeah, so it's not always that easy. Sometimes a little bit of persuasion is necessary. This one's been pretty fiddly. It was quite a hard spring, but once you've got one edge up, you can just sort of work it round. And then it's off. So once that collar's off, once the retaining clip's off, the collar will come off, the spring underneath, and then the whole gear itself. Just be careful, depending on the make, there can be little washers that stick to here and are easy to lose. So underneath you'll see this spiral part, and that's what drives the Bendix gear up to engage with the ring gear on the flywheel, and then after that there's a bit of a smooth shaft. Okay, so we've had a look at how these work. We've pulled this one apart. Now it's time to have a look at sort of what can go wrong. Now, the thread can get damaged on the shaft, although it's not that common. But what's more common is essentially that it just gets a little bit gummed up. Now, the effect of it getting gummed up is a bit like this bolt. So if I have the inertia of the Bendix gear here, and I turn the bolt, it'll start to rise up the shaft, so that's the starter motor turning. But you can imagine that if that inertia isn't enough to overcome the friction, all that actually happens is they spin together and the bolt actually doesn't rise up. So if it's spinning and it's staying in place, what it means is there's enough friction in this to stop that relative motion. They're just moving together, they're locked together. Now that can happen from a full-on lockup through to
shades of grey in between. That there's a bit of friction. It spins up pretty quickly. It spins a little bit, doesn't go all the way up. It sort of just kisses the flywheel and comes down, or engages the flywheel and quickly drops away again. So all those kind of odd symptoms you might get with a starter motor can be caused by friction between the gear and the shaft here. So what I'll do, we saw that demonstration at the beginning where when it spins it goes up and comes down again. So what I'm going to do now is just clean this up a little bit. I'll just put a little bit of Loctite on it to sort of simulate it being a bit gummed up. I'll put it back together and then we'll start it and you'll see what happens.
Right, so now this has had a chance to set for a little bit. I'll just crank the power on and we'll show you what happens. So if we power it up now, it spins but it doesn't rise up. And that's because now when it spins up, instantly this Bendix gear is now spinning at the exact same speed as the shaft because it's kind of locked to it essentially. And it's only the relative motion of the two that makes it rise up. So the same with our bolt. If we turn the bolt and hold the nut still, the nut moves along the shaft. If we turn the nut and the bolt together, nothing happens. And that's what's happening here. So if you're having this problem, you've probably got Loctite on your starter motor. So what you're really going to have is old grease that's gone hard. It happens a lot. Grease can be great when it's new and it can actually become almost an adhesive when it's old. So the solution to this problem is to dismantle this, clean it and lubricate it. That's all it is. It can kind of present itself in some weird ways. This is obviously locked hard onto the shaft now, so as soon as the shaft spins, this gear is spinning at the exact same speed as the shaft, so you don't get that relative motion that causes it to rise up. The friction in that Loctite now is more than enough to overcome the inertia of the weight of this pinion Bendix gear. In this case, it's kind of obvious. It spins and you go, right, something's up. I mean, admittedly, like until you understand how it works, it's not that obvious, but once you know how it works, you think, right, you know, this is the problem. This is spinning at the same speed. It must be somehow fused to the shaft. But you can get situations where there's increased friction, but it's not locked like this. And that's when you can get a whole range of weird symptoms where it's either rising up and then coming down before it really engages. It engages quite briefly and comes down. All sorts of symptoms you can get. Symptoms that might look like a failing motor itself or look like a weak battery or whatever, but it's actually just there's too much friction between this gear and the shaft. So what I'll do now, I'm going to use this, because I've taken this collar off a few times, this locking pin, it's now a little bit tight, so I can no longer push this quite so easily. So I'll just knock this down. I'll take this little collar off again. Because my pliers don't fit in, I've actually just been using a screwdriver to sort of get in here and pry it off. Hence it's a little bit overexpanded now. But I'm going to pull this off again, hopefully, and then we'll clean it up. I've brushed this shaft, the thread in the shaft up here, and cleaned out this gear a little bit. What I'm going to do now is lubricate it with a little bit of this PTFE sort of dry lubricant. This is what I've seen recommended for this application. Before I put this together, there's one thing I will show you. Is this unit has the one-way gear mechanism. So this can actually free spin one way, but it locks the other. And the sort of the opposite thread to this spiral here is in this part. So this part can spin freely in this direction, and this comes into play in that it'll turn the flywheel when it's turned the other way, but then as soon as the flywheel's moving faster than the pinion gear is allowed to free spin. So another thing to check with your starter motor is that it can turn in the correct way to push the starter motor, but as soon as the starter motor's moving faster than the pinion relative, it's allowed to free spin in the other direction. So another check you can do if you're having some weird symptoms with your pinion gear engaging. Now I've got this cleaned up and lubricated again. If I crank it, it's not perfect, but it's better than it was. What you'll see, same thing, it rises up and drops down again. So the take-home message really is that if you have any issues with this rising up and down, it's either the one-way ratchet mechanism inside this Bendix unit, the threads are damaged, or I think most commonly by a long shot is that there's a bit of dried up grease that's essentially reducing or increasing the friction between the gear and the shaft, meaning they spin together, and by spinning together they don't have any relative motion. So I hope this video helps if you're having this problem where either you crank the motor and you hear the Bendix gear just spinning and not engaging at all, or spinning, engaging and then disengaging from the flywheel before the motor starts, so sort of prematurely disengaging. All those problems will be caused by varying degrees of friction on that threaded part of the starter motor shaft, and are all fixed by simply disassembling, cleaning, lubricating with some sort of dry lubricant and reassembling. So if you're having this problem, I'd definitely be trying this first. You can get similar symptoms from something more serious, a sort of a weakness in the motor from a bad, like a solenoid disengaging, the ignition switch, all sorts of things. But this is quite a common problem. And when you do get it, it can be a little bit tricky to diagnose if you don't really understand how this mechanism works, and hopefully this video helps you with that. So thanks for watching. If you enjoyed this video, please rate, comment and subscribe, and I'll catch you next time. See ya.